Hey guys, this is me again for another video on the noname project, which is this programming language to write Rust-like programs that you can prove the execution of and verify. I have a series of videos on that, and this is a new video on methods that I just managed to implement. And so I'm gonna test it and see if it works. I actually didn't really, I just managed to like run an example and finally built. So I don't really know if it actually works or if I forgot something. So maybe we can debug that together and see if it works. And you can also learn how um, some of these gates are converted. Some of these programs are converted into gates for an arithmetic circuit, or not really an arithmetic circuit, but more like a like custom gates and plonk gates for kimchi. And if you don't understand these words, just refer to the description of the video. I think you have a series of videos on Plonk and all of that, so you can go back to that. Anyway, so if I run this example with the debug, so basically what I managed to do is that I can create a struct with fields that have field elements. I'm not sure if I can create a struct that has struct inside. I haven't really tried. It is possible it would work because basically the code is like flexible that you're supposed to be able to throw stuff at them at the framework and it should just work. Unless usually I just I kind of like start as a TDD approach, test-driven development, where I just have one example and just want to be able to compile it. And if I have some branches in my compiler that don't really matter for my example, I just write to do or unimplemented or something like that. So usually that works, but maybe some other stuff doesn't work. Anyway, let's compile that with debug and let's look also at that. In Rust, you would write like implementation house and then like your functions on the thing. This is Copilot completing that for me, I guess. And I don't really like this approach because you can end up like writing like pretty long functions and be in the middle of functions and you never have any idea what this function is implemented on. And you always have to, basically, the nice thing about your Rust analyzer now is that it gives you a hint here of the function you're in, but it doesn't really tell you what you're implementing on. And so that's a bit annoying, and I don't want that for noname, my language. So what I do is that every time you implement something on a tab view, I have to write this kind of thing. And it should be pretty easy to remember because this is exactly the same syntax as a normal method call when you're using the thing. And also, basically, I want to do something like like that. For example, doors field, and I want to be capable of writing something like this. And that when I write it, also I don't have to do house colon new, but instead I think house new is good enough. I'm not sure why Rust has you put the column when it's a static method. I really don't see the point, so I think that's good enough. If someone knows if there's really an advantage to using that colon when it's a static method, then let me know. Otherwise, I'm not going to use it. Anyway, okay, I'm not sure if that's going to work, so I'm just going to comment that for now. But yeah, that's how you write a method. I think I still don't support passing types other than field or arrays of field in a method, so I'm not going to be able to like pass an actual like house or something like that here. But it shouldn't be too complicated to implement, so we'll see. And okay, so let's look at that example. Sorry again. So public input here, doors, it has a public input, so it uses double generic gate for that with the left input set to 1. And then all of that like type, custom type creation or structure creation doesn't really matter. It's just about routing variables internally, but there's no constraint created. So basically the only constraint that's going to be created is when we call host.verify3 is gonna, like that assert equal is gonna make sure that 3 on the left is equal to self doors to that that public input that we passed, right? And indeed, we have -3. Um, Interestingly, it doesn't matter if you put the constant on the left or on the right, it's always going to put it on the right with the double generic gate, and always put the variable part on the left. Doesn't really matter, but that's just an implementation detail. And the wiring should make sure that what's on the left here, what's 1 times the left input. So what's on the left here is the public input that we constrain on gate 0. So let's check the wiring. What's on gate 0, the public input, indeed goes to the left input of the gate 1. We got the wiring from the public input to that as third equal. Everything works. 3, 3. That's what I passed in my. Oh, let me close that. That's what I passed in my argument here for the public inputs, number 3. So all good, all good. Okay, so that's a pretty simple example. Actually, let me try to compile that. I just want to see if it works. I'm not sure it's gonna work, but let's see. Okay, so invalid token. Oh, okay, return. I'm too used to writing Rust. Not implemented. So yeah, so I just reached something that I'm not. I guess when there is a return type, I don't implement. Oh, return type other than field, then I don't implement that. This is the compiler on the right. So never mind, this is not gonna work yet. Can I do something like, okay, can I return a field then? Do like return doors. Pretty simple. Is that gonna compile? It seems to compile. Let's remove the debug. It's compiling to the same stuff. Yeah, nothing has changed. Can we use that to return doors +1? And can we do doors equal house new doors? And that should not verify because it's going to create a new house with 4 doors instead of 3, and so that thing here should not verify. Let's see. Variable used is not defined anywhere. Variable used is not defined anywhere. How's the new? I'm not sure why I cannot write that like this. Let's try. I hope I get the same error. Yeah, okay, I get the same error. House new. Oh yeah, okay. I guess he doesn't understand static method calls yet. Okay, so let me make a note of that. Static method call. So I haven't implemented that, but that's fine. Yeah, I'm not sure exactly where it's gonna break, but no, it doesn't matter. So let me do this thing. Let's just try an example that's a bit more complicated just to make sure that things work. So let's do X, house X, Y, Z, okay? And let's make sure that house.verify asserts that X equal self X, and maybe let's make sure that X plus 2 equals self Z, and here let's try self X plus 1 equals self Y. Just trying different ways of checking things. And here we'll do X equal, let's pass X, X, Y, X plus 1, Z, X plus 2. Let's try that. X. Okay, that's not gonna work. I guess that will verify here. Let's try. Oh no, that was correct. And here I'm passing X. Okay, let's try that. It seems like it's working. And if I do 4 here, this is gonna. Okay, there's an error. That's good. What if I do +3 here? Yeah, that doesn't work. What if I do +2 here? doesn't work either. So it looks like things work just by like the assertions don't pass when it's not supposed to pass. So that's already a good news. We can check the debug mode just to see if it's making sense. Right, and I guess we can open it into different windows like that. We can scroll at the same time. Cargo that. We can get the wiring here on the right. Okay, and so okay, public inputs 0 gates. Okay, then this here doesn't create a constraint. Again, constructing a type doesn't, or a struct doesn't create a constraint, right? Here we are adding something, and so we are going to create a constraint here for that. And actually, um, I'm not sure if this gets constrained right away. I guess they do get constrained right away. Okay, so this addition creates a new constant. Add a constant with a variable, so not a constant, a variable. And so here we have the left variable is added to 1, and the minus the output equals 0, so equal the output. That's the same. So get 1 is the value y, and get 2 is the value z. And here we have the left input plus 2 equals minus output. Minus output equals 0. Okay, we just have to wire the public input to these two gates, right? So the wiring, wire the public input here to these two gates, right? Public inputs, gate 1, gate 2. And I guess X is also used in data assert equal and also used in data assert equal because I'm guessing X and self X is the same value. So we'll see about that. Let's ignore that for now. Okay, assert equal get number 3, X self X. What is that minus 3 here? That doesn't look good. Is that a bug? Oh no, X, okay, I shouldn't use these, let's use different variables. Let's use check value, right? So we don't make a mistake. Or let's call it V, VV. And let's do that again, so it's not confusing. So yeah, so X or self X is the same, right? X or self X is the same. It's only going to be wired to, I guess, the wiring here. To I believe it's on the right here in that assert equal, but as I said, constants are usually on the left, right? So 3 with the left inputs. And same thing here. Well, we'll see about gate 4. Just to verify, indeed the minus 3 is in the right, so it's confusing, right? The constant is on the left, but did I say that? The variable is on the right, but it's actually the variable is actually put on the left. It's variable minus constant, variable minus that constant. And indeed, this means the left input, 0. Okay, get 4, self x plus 1. So I'm guessing we're not looking at the assert equal here. We're just doing the addition here at a constant with a variable. So 1 plus the constant here. And yeah, we have to make sure that that is, let's get number 4 is the same as all of these x's and self x. Whew. Okay, a lot of wiring, but it all makes sense. Everything's correct as far as I can tell. The assert equal finally happens between this, which is the output of get 4. So if we look at get 5, not okay, get 5, the left of get 5, right? The left input of get 5 is indeed the result of this addition, which is in gate 2 and the output value, right? Get 4 and the output value. And going back here, the self y here is the output of this x plus 1, which where did we get 1? It's from get 1, okay. So get one, the result of get one. We're getting pretty good at reading this result. Maybe that'd be fun to write result output value of get one. The problem is that if get one is not a generic gate, that wouldn't mean the same thing. So maybe as a debugging thing, I could actually write that output of get one. But anyway, if that's useful for someone, let me know. It's going to get 5 and to the right hand side, the right inputs of get 5. Okay, and now we have a third equal, so this thing and self z. So I guess one of them is a constant, right? Yeah, there's a constant. So self z is 5. Is that? No, that's not a constant. Oh no, v plus 2 is the constant, right? V is 3, so this is 5. That's a constant. And even though it's on the left-hand side, we're using the constant thing. And the right-hand side is the variable, so we put in the left input. And so what is self z? The z is x plus 2. It's in gate 2. Okay, it's the result of gate 2. So let's look at that. The result of gate 2 goes into gate 6 and the left input of gate 6, which is what we have there. And we have the 3 asserts. Oh, sorry, 1 assert, 2 asserts. Are we missing 1 assert? Oh, no, sorry. This is the second assert. This is the third assert. Where's the first assert? Okay, that's the first assert. So we have all of them. So we have the 3 asserts, and they all, yeah, they're all correct. I believe they're all correct. And the wiring made sense. At least to me, made sense. Hopefully, it made sense to whoever's watching that. We can look at the witness, but at this point, the proof pass is created and verified. I don't really like looking at witnesses. Okay, I can do it very quickly. Public input is the value 3. This is what I pass as public input. 3 plus 1 is 4. 3 plus 1 is 4. Gate 2 is 3 plus 2 is 5. 3 plus 2 is 5. And the 2 is not here because it's a constant. So it's not part of the execution trace. It's part of the circuit. Gate 3 is the assertion. That's 3, 0. What is this? Oh yeah, because assertion was a constant. So 3 minus the constant that doesn't appear in the execution trace because it's part of the circuit. Here we add a constant with a variable, I guess 3 plus 1, is that what? And we're using constant again, so it doesn't appear here, but 3 plus 1 is equal to 4. That makes sense to me. And x is, I guess, 3. Gate 5 is, so now we have 2 different variables, right? So we have on one side 4 and on the other side 4. So 4 and 4. And finally, we have a variable and constant. So the variable is 5 minus the constant 5. Here, everything looks correct. Cool. Yeah, should I leave it at that? I guess just for fun, let's see if I can do a struct inside a struct. I don't know if it's gonna work, but let's see. X field, and then let's say A is A. Let's just compile that just to see if we get an error. Incorrect number of fields declared for the house struct declaration. Yes, that makes sense. Let's create, let A equals A X. What was equal X? Yes. And let's pass A here. A. And it looks like it's working. I'm pleasantly surprised. Let's remove all of these asserts. Can I have an empty function? No, I cannot. So I can do return VV plus VV. These things return a field. I don't know if I don't use the return value. Is it going to complain? Expression that return a value are forbidden as statements. Yeah, so it's complaining because I'm not using the return value. So maybe I'll do this. And no, it works. Okay. Um, okay, I just want to take a note somewhere that the error we got earlier, let me get that error again. I want to improve that error. That wasn't great. Expressions that return value of forbidden as statements. Okay, so let's change that to the return value is unused. The return value is unused. Okay, I can think of something better, but I think that's a better error. The return value, um, a return value is not used. Maybe is not used. All right. Anyway, that's not a great error. Name symbol unused return value. Okay, that'll be better. So let's try to create a constraint on that A just to make sure it works. I'll verify. Let's do assert that self dot a. Oh, I don't think that's gonna work because I cannot do self dot a dot x. I don't think that's gonna work. Yeah. So I guess I'll have to fix that. So for now, functions instead of other functions don't really work. But it's fine. It's still useful. I think people can still write useful instructions using that. Can I call a function from another function or another method? Let's do assert self, and let's put that assert here. Um, host.assert. So I think I need to have these declared before. Like I don't do a very clever compiler pass. Everything has to be in order. I don't think that's going to be a problem, but you know. And let's check that self.x equals VV. Let's pass the VV here. It's a pretty simple one. Okay, is this gonna? I hope that compiles. Oof, oof. Okay, so it thinks there's a variable used. Variable used is not defined anywhere. I believe this is of the let y equals. That's oh no, it's not even that. Variable used. Oh, house assert. Variable used not defined. Oh yeah, again, there's no I'm stupid. Self. Okay, so that seems to work. That's a lot of gates. That's a lot of gates. Something fishy is going on. Okay, so um, public inputs x plus one, x plus two, whatever. Oh, okay, I know what's going on. So here I'm using the equals equals. So it's going to try and convert that to like a Boolean, and that's what takes a lot of gates. So if you don't want, this is actually quite inefficient. If you know you can just write that, then you should write that. That's very cool, which is much more optimized. Okay, much better. So now we only have one assert self xxvv. It asserts that it's equal to -3, which is, yeah, sorry, equal to 3, constant here. And just need to make sure the wiring, so get the left input of get 3 is equal to the public inputs. Public inputs, left input of get 3. So that works. A function or method can call another method. So that is nice. So we found some stuff that doesn't work yet, that is not implemented yet, and all the stuff that's implemented seems to lead to correct constraints. Everything seems to be sound. So cool. I'm gonna stop here, but I think the next step for me is going to be able to implement the Sudoku example, um, which might not work because I think this is not implemented yet. Actually, we can even try to run it. Oh, I'm not gonna do that now. But I think this is kind of like the final step of my my compiler is to like, or my language is to be able to like compile this Sudoku example. And once I have that, I'll just need to make sure um, I implement more constraints. So right now you cannot do much more than addition, but I want people to be able to do subtraction or like inequalities and these kind of things. So that's what's going to be on the plate for me. Anyway, if you want to play with it, please go check the noname project on GitHub, and yeah, give me some feedback. Let me know what you think. It seems like a interesting toy to play with.